But now there's an interim mental display. This is your mind. From that, there is a theoretical deduction or an explanation. That explanation in quantum produces the cat in the quantum world. These are waves. What you're doing now is interpreting, according to quantum theory, you're interpreting the waves that come in here in terms of the classical world that you actually see. Okay? Dualism back again. Plato. This is what you see in the cave. This is what we now believe to be in the reality if we believe in quantum mechanics. Okay. Eric Reiter is going to talk about an experiment that he's done, which shows something, if we follow this, which shows something interesting. Here is the electromagnetic field. It hits a detector, and the detector produces little flashes, which you see. Now, the problem is that the wavelength is very large, about 1,000 times larger than the atoms. Right? So the people that did these first experiments, Einstein and his wife and so on, and the people at that point, they said, how can a huge wave, if it's an electromagnetic wave, be absorbed by a little tiny atom? You know, it's 1,000 times smaller, right? And the answer was, it can't. It must be a particle. In order for that distributed energy to suddenly hit something that small, it must be originally a particle. So they projected photons into the world. Okay? We do this all the time. Scientists do it all the time. It needs to be straightened out. What's the result of that? They projected photons in here, and then they said, well, wait a minute. It doesn't always act like a particle. It sometimes acts like a wave, and it depends how I look at it. Okay, so again, they're saying, wow, here is something that I can't quite explain. I'm going to postulate something. I'm going to postulate the wave-particle duality. Nonsense. It's always been an electromagnetic wave. Well, that's also a projection. It's a better one. And the change takes place in the detector itself. That's where it turns out that one can, nanotechnologies do it, but transistor radios have got these, they're called active resonant antennas. Very small antennas can grab energy from very large pieces, and that's actually what atoms probably are. So now Eric is going to show you something, and that may be an experiment to actually prove what I'm saying here. So I'm just going to skip this because the person I'm going to introduce right now is Henry Stapp.